talking about seconds. So that's 30, you got to put your units in, 32 feet per second. Now, what did we say? I've erased the slope thing, but what did we say about the first slope we were looking for? That it would be blank and blank.
Positive and steep.
Positive and steep. Is a slope of 32 over 1 steep?
Yeah.
Yeah, I wouldn't want to go down a flight of stairs where one step forward was 32 feet down. That would suck.
It'd be like a slide.
Be like a slide. Okay, now I'm going to add a
That would
question.
not be a slide.
It'd be a falling slide.
It would be the Superman.
Okay, now B.
Painful slide.
Okay. It says find the average rate of change. Yes, sir.
For A, it says from t equals 0 to t equals 2.
Yes.
Y is...
Because it's high, starting to what it was.
Y is which?
Wait, Y is both 0 and 2?
Because you put in T for 0, 0 for T, excuse me, and then you put in 2 for H. Because this is minus 32T minus 16H plus 64 is what we got. And H is the distance between the two time values we're talking about.
Oh. Okay.
That's the tricky part. Okay? So let's see if this helps. The next part, part B, says from T equals 2. I can't type. Good Lord. Third try. 2. T equals 4. Okay, from T equals 2 to T equals 4, what's T going to equal? And what will H equal?
2.
H, 2, that will equal 2 again, correct, because the distance from 2 to 4 is 2.
Okay.
The lower independent variable, whatever's on the x-axis. T will start at the lower one, and then H will be the distance between the two. Average rate of change, in this case, is going to equal negative 32 times 2
Negative 16 times 2.
minus 16. Yep, H is 2 again, plus 64. And what's this going to get me?
Negative 32. Negative 32.
Yep, this will get me negative 32 feet per second. What did we say about the first slope, the second slope?
Maybe negative and be steep.
Negative and be steep. This is exactly the same steepness, and it is negative. Okay? So that works.
Can you answer my question?
Hold on a second. Part C said, what do the signs and the answers to Part A and Part B mean in terms of the direction of the ball's motion? Well, which way was it going on the first? Up. And which way was it going on the second slope I drew? Down. So here's how you should write that and how you should think of that. This phrasing is actually pretty important.
I thought we only had to do A-B.
Is the question
But there was
this
only
thing
A,
have
B.
to be, like,
No,
is
there's
it
a
going to
C.
be on our quiz?
It was C,
Yeah.
never mind.
It's not a quiz, it's a test.
Oh, sorry.
It's okay. All right, so positive means,
There.
okay, guys,
No,
positive change, let me phrase this carefully. Positive rate of change in this case means increasing height. When we talk about rate of change, and this is something that maybe was not said out loud before, whenever we talk about rate of change, we're talking about the dependent variable, the y, the s of t in this case, okay? So it's in this case, s of t means height, right? So a positive rate of change means increasing height in this case. So what does that mean a negative rate of change means? Decreasing height. So, but whenever we talk about what's happening to a function, we're talking about changes, I'm writing it wrong, we're talking about changes in the y value. Keep that in mind because that can actually, I can forget to say that sometimes, that what we're talking about is the y value, the
Wait,
dependent variable.
that's what we're mostly focused on, or is that what we're literally just talking about?
That's a great question. When we talk about the such and such of a function, the rate of change of a function, the increasing nature of a function, the minimum or maximum of a function, like we talked about before, with that, we're always talking about when is the y value increasing? When is the y at a maximum? When is the y at a minimum? The only exception to that so far is when I ask for the domain of a function. Because then that means what are the x's doing? Everything else means what are the y values doing? Okay? Stay with us, Chris.
I'm staying with you.
Excellent. Okay, Brandon, you still have a question before I go on to an expansion of this? You want to make it more interesting. Pardon? Okay. The part B of this said, what's the average rate of change from 2 seconds to 4 seconds?
Oh,
They gave it to you, yeah. It gave us 2 to 4. And when you're using a difference quotient, t is always your initial value, and h is always the distance from between the two values.
Okay, but in A, they don't give us a 0.
Yeah, in A they said find between the time it was thrown. The time it was thrown is going to be t equals 0.
How do you know that?
Because it says a person standing on the roof of a building throws a ball directly upward. That's a little hard to read out of that one, Brandon, actually. I won't lie, that's a little bit different. That is a little rough to read out of it. Yeah, t equals 0 is always, I guess it's just a physics problem. T equals 0 is always when it begins, when it releases, when you start something. Okay?
I have a question.
Yes.
I forgot. Do those things have like sound in them?
Yes.
Okay. I
Here's a
couldn't
microphone.
remember.
Yeah, if you go on YouTube and look at it.
Like you hear the noise.
Yeah,
The voice. I mean,
Okay,
I just forgot to look at it this weekend.
that's fine. You didn't have to look at it, but yeah,
Yeah.
You're on it. Okay,
I'm
here's what
on
I'm
it,
adding
wow.
to it now before I turn you loose on the review problems. And let's see if we can do this quickly. But, okay.
should we write this in the notes?
Yes, new notes, write this down, or just pay attention and I'll post this. How can you use the difference quotient, okay, to estimate the instantaneous rate of change when the ball hits the ground? Okay, this is an interesting idea, and I'm going to go back to my graph here for a second, if my computer will let me. Okay, here's my graph. I'm going to zoom in. Okay, when the ball hits the ground, first off, let's check some things. And we'll use the graph. Pardon?
Okay.
Hey guys, stay with me. This is...
That's a speed graph.
Yeah, hang on.
That just looks slightly painful.
What looks slightly painful what I was doing?
Well, if that was a physical object, that just looks slightly painful.
What do you mean? I don't get
Like to ski down that, let's say, that just looks.
Yeah, it would be. But okay.
As
Yeah.
good would say, you would die.
Alright.
Wait, is it like never ending?
Well, hold on. Some of this is stuff that you guys who've been in physics may know better than others, but let's see who knows what. Okay, guys.
Okay, what?
This thing here. Hey, Chris, stand up again. You're starting to waver on it. Stand up for me. Okay. What does this point mean right here? It's on the x-axis. It's the x-intercept of this parabola. What does that mean in terms of the ball that was thrown?
That's where it is.
Ending
That's where it
point.
crashes.
That's where it crashes.
Violently crashes.
This is where it hits the ground. And you know what, Lauren? I want to know exactly how violently it crashed.
Like enough to smash
Is this
the
where you
smithereens
have
out of
Yes.
your brain.
Now, so pay attention, okay, guys? This is, guys,
Like
we did this once before. This is probably the hardest thing on the test. I really need your full attention on it. Okay. This is the moment where it hits the ground.
Sorry, what?
Lauren, I want to know exactly how violently it hits the ground. Average rate of change. That is an average speed. Okay, that's an average change in position here. So what I want to find out, I need to see a trend of smaller and smaller rates of change. Now, according to this is at t equals 5. Okay? So that means this thing takes 5 seconds from the moment it goes to the roof up to here. What I'm going to do is I'm going to compare the slope of the secant line here, the slope of a closer secant line, and the slopes of closer and closer secant lines. I need to see a trend. And I'll show you what that means in a second. So we're going to do this at least a couple of times. We're going to start with something very small. If someone has a calculator, they can help me out with this. Fastest thing to do would be to put this
What type of
parabola,
calculator would you like?
a graphing calculator, and someone who's really good with a trace button.
Sort of.
No, I'm not good with that.
Okay. Now, here's where finding the difference quotient really comes in handy, because the difference quotient will give me the slopes of all these lines, right? Correct? Do you guys understand the difference quotient gives me the slopes of these secant lines? Good. Okay, so do you have a visual picture of what we're doing here? Okay, good.
To an extent.
All right. Actually, the calculator may not be needed in trace mode. Don't put that in yet with the difference quotient. It shouldn't be necessary. Okay, now I'm going to go back. We're going to hide the picture now.
I have a question again.
Yes.